This is Amanda Martinez, and this is my reassessment on work energy. So the problem asks you to find H, the final H of the car that's moving 20 meters per second down a hill, then coasts up a hill. And they ask you to find the highest point, H. So I drew my diagram to get a visual so I could see how the car was going, and since the car starts up here, it has kinetic energy to start with and it has potential energy, but once it reaches here it only has kinetic energy because it's at the horizontal, so the potential energy is zero. So since the potential energy is zero, you have to split this problem and do the work energy, use the work energy conservation formula from here to when potential energy reaches zero, and then also, so you do like two different parts. That would be part A, and then you have to do it from when it goes from zero back up again to have potential energy again, and so you have to split that into part B. So for part A, you use the work energy conservation formula, which is work non-conservative equals change in kinetic energy plus the change in potential energy. And you get that since the question says to ignore air resistance and friction, that becomes zero. So you get zero equals kinetic energy final minus kinetic energy initial plus potential energy final, potential energy minus potential energy initial. So you know that the car, when it starts, it has initial kinetic energy and initial potential energy, and then once it hits here it has only kinetic energy. So the final potential energy would be zero, so you get kinetic energy final minus kinetic energy initial minus potential energy. And then once you get that, you solve for the final kinetic energy, because the final kinetic energy here is also the same as the initial kinetic energy for part B, from starting, because the card's going from here to here, and it's starting from where it ended at part A. So you get that the kinetic energy final equals initial kinetic energy plus initial potential energy. So you get kinetic energy final equals 1/2 mv squared plus mgy, and so I decided to call this A to make it simpler for part B. So for part B, you're doing from when the car is at the horizontal, so the potential energy is zero and goes up to the highest point that it can reach while it's coasting. So you use the same work energy conservation formula, and the final kinetic energy is zero because it comes to a stop when it hits the highest point. The initial kinetic energy is the same as the final for the first part, and then you have final potential energy, but you don't have any initial potential energy because it starts from at the horizontal. So you get that zero, and also this equals zero because the question said to ignore air resistance and friction forces. So you get zero equals negative initial kinetic energy plus potential energy final. So since the initial kinetic energy here is the same as the final kinetic energy here, you can just say that this is A. So you can say 0 equals A, negative A plus mgy. So then you just solve for y, and you get that y, which I wrote here, h equals A over mg. So once you get h equals A over mg, you put in this for A. So then you get h equals 1/2 mv squared plus mgy over mg, and all the m's cancel out. So then you just get h equals 1/2 v squared plus gy over g. And then once you put all your values in for your variables and you calculate it, you get that the maximum height for the car was 25.4 meters.